Okay, guys. So this is the last video of section 6.4 video 3. I'm giving you very detailed notes because I know from my experience that students struggle a little bit with logarithmic functions. So I'm trying to give you very detailed notes, especially that we don't meet face to face. So in this example, we're going to talk about graphing, logarithmic functions, and its inverse. So I'm going to do one example from your textbook, page 449. This is number 73. Okay, and here they give you the logarithmic function f of x equal ln of x plus 4. They want you to do a couple of things. A, graph f of x using transformations. B, find the domain and range of f of x. C, they want you to also graph the inverse. Okay. And D, find the domain and range of inverse. Okay, so let's do one example. Okay, let's start with A. So you have f of x equal ln of x plus 4. So original, or I will call parent function, it's the graph y equal ln of x. So you want to graph y is equal ln of x, which we graphed before. Don't forget that if you don't see base and you see ln, that means the base is equal e. Okay, so base equal e. Okay, so how are you going to graph it? 3 major points. So it's 1 comma 0, then it's base comma 1, and then it's 1 over base negative 1. So in our case, we're going to have base, which is e comma 1, and here we're going to have 1 over e comma negative 1. Since you need to graph it by hand, let's just estimate that e it's about 2.72, 1, and 1 over e it's about 0.37, negative 1. Okay, so let's graph this one, which we graphed in previous lecture. Okay. Okay, so I have 0.1 comma 0, 2.72 comma 1, 2.72 comma 1, that will be here, and 0.37 comma negative 1, 0.37 comma negative 1. So I graph, again, it should not touch it, guys, but it's approach. I graph y is equal ln of x. So in orange is y equal ln of x, parent function. However, our graph is ln of x plus 4. So that plus 4, we know that here we're going to have horizontal shift And when you have horizontal shift, it's always opposite of what you see, which means horizontal shift 4 units to the left. Okay, so what's going to happen? You have the 3 major points. Each of the 3 points which you graph it, you want to push it 4 units to the left. Okay, and also don't forget that here we have that vertical asymptote here. Okay, so I'm going to use the same graph. So now we're going to graph y is equal ln of x plus 4. So I'm going to push each point 4 units to the left, which means if you had originally point 1 comma 0, so now you will have point, take your original x coordinate and subtract 4. Y will stay the same, so we'll have a point negative 3 comma 0. So let me find negative 3 comma 0 right here. Then the next point which we had was 2.72 comma 1. So when we shifting this graph 4 units to the left, you're going to take original x coordinate, which was 2.72, subtract 4, y coordinate stay the same, and that will give us negative 1.28, comma 1. So negative 1.28, somewhere here, comma 1. So that was pushing this one right here. And the third point, which originally was 0.37 comma negative 1, 0.37 comma negative 1, we have that horizontal shift 4 units to the left, take original x coordinate 0.37, subtract 4, y coordinate stay the same. So that will give us negative 3.63 comma negative 1. And so this point right here will switch to negative 3.63 somewhere here comma negative 1. And couple things here. You guys we have originally that vertical asymptote x equals 0. So the vertical asymptote also will be shift 4 units to the left. So right now, the new vertical asymptote will be x equal negative 4. So my graph will be approaching that vertical asymptote, but it won't intersect. So this is y equal ln of x plus 4. Okay, so we have it. So that was part A, graph using transformation. Find the domain and range of the graph. Let me just... So here we graph it. It's in blue. So domain of y equal ln of x plus 4. From the graph, you guys can see that domain, that's our x value. So x's has to be greater than negative 4. So all the x is greater than negative 4, which means from negative 4 to positive infinity. Okay, and range, that's the y values. The y values of our blue graph, it's still from negative infinity to positive infinity. So that was part B from this problem. Now, part C, they want you to graph the inverse. So I will graph it using the same graph. Hope it's not too much. C, graph the inverse of y is equal ln of x plus 4. Okay, so we're going to graph the inverse. function. Let's graph it, and that graph will be in red. So what I'm going to do, I'm going to use the points right here of function logarithm of x plus 4 natural log, and now just switch the coordinates. Okay, so negative 3 comma 0 will become 0 comma negative 3. Then the point negative 1.28 comma 1 will become 1, negative 1.28, switch x with y, and the point negative 3.63 comma negative 1 will become negative 1, negative 3.63. Okay, so 0 comma negative 3 right here. Then we have 1 comma negative 1.28, 1 comma negative 1.28 somewhere here. And then we have negative 1, negative 3.63, negative 1, negative 3, 1, 2, 3, 6, 3, somewhere here. Okay, and the vertical asymptote was x equal negative 4. That means that we will have horizontal asymptote. Let's just extend it. Y equal negative 4. So negative 1, negative 2. Right here, negative 4. So that will be the horizontal asymptote. So let me graph this function, and it's going to look like this. Okay, so the pink one, it's the inverse function. That's the inverse function. Okay, and like you guys see, the inverse function and the blue function, they should be symmetric with respect to the y equal x-axis. Okay, right here. Okay, y equal x, which it looks like, again, this is done by the hand, but we can see that they are inverses. Okay, since we have it, again, the red graph, it's the inverse. We need to find the domain. So here, domain of inverse is the same as range of original of f of x. So range of f of x was from negative infinity to positive infinity. So we have it. It's from negative infinity to positive infinity. And now range of inverse, it's equal to domain of the blue function of f of x. So the domain of the blue function is from negative 4 to infinity, and it makes sense. That's the y values, which goes from negative 4 to infinity. Okay, so we did one problem like that, just reviewing a little bit of transformations. Okay, finally we're moving to something what it's the most important here, okay, from this video, which means solving logarithmic equations. Super important. Solving logarithmic equations. Okay, I will give you 3 notes about that. Okay, first of all, you guys need to remember that logarithmic function has restricted domain, so you have to discard the extraneous solutions. Which is fake solutions. Okay, why? Because don't forget that domain of logarithmic function, okay, remember to always find the domain of logarithmic function. So you will know if your solution satisfies the domain logarithmic function, which means expression next to log greater than 0. Okay, so that's one thing what we need to remember. Second, you're going to use one-to-one property to solve equations. So let me give you an example of one-to-one property. Let's say you will be solving log base 2 of x plus 5. It's equal log base 2 of 9. So here you can apply one-to-one property because you have log on the left side, log on the right side, and they both have the same basis. So we can just ignore them, okay? And since those equations are equal, you're just going to compare the expressions next to log. So you will be solving only x plus 5 equal 9, and that will give you that x is equal 4, okay? So this is one-to-one property. And one more note about solving. Change the logarithmic equation to exponential form. Okay, using the fact that y it's equal log base a of x means that base to the power of y it's equal x. So you're switching the position of x and y. Okay, so let's start practicing. Okay, so I'm going to use problems from your textbook. This is page 450, and we're solving number 91. You need to solve. Okay, and we have log base 2 of 2x plus 1 equal 3. So again, domain, let's just review the domain. You always take the expression which is next to log, and you have to make sure that it's positive, greater than 0. So when you solve for x, you're getting that x is greater than 1/2. Okay, why it's important to have that domain on the right side? Because you don't want to have those extraneous solutions. So how are you going to solve this one? Okay, you're going to change logarithmic function to exponential. And I teach you how to do that. Okay, you always have to identify what is the base. The base it's 2. So we're going to have 2 to the power of something, it's equal something. So base of logarithmic function is the same as base of exponential function, okay? And we remember, since they are inverses, that x and y they're switching the position. So right now, next to base, I'm going to have 3, and outside it's going to be 2x plus 1. So we switch to exponential. When you switch, solve for x. So we have 2 to the third power, which is 8. It's equal 2x plus 1. Let's solve for x. Subtract 1 from both sides. We're getting 7. It's equal 2x. And divide each by 2. And we're getting x, it's equal 7 over 2. So x equals 7 over 2 definitely satisfy the domain, because the domain is all the x is greater than 1/2. So this is our answer. Okay, so that was the example how you change the logarithmic equation to exponential. Let's do more. Next one will be number 93. Also, from page 450, you guys can try to solve it by yourself. You can pause the video and then check with my answers. So you have log of base of x of 4 equal to. So when you see log, what you're going to do, you're going to change to exponent. Okay, so always start with identify the base first. Okay, so to change to exponential, you need base, you need exponent, equal sign, and you need a number. Since we know base already, which is x, so we're going to have x, okay, which is our base. Now I need exponent. So don't forget that when you change to exponential, those expressions switch the position. So next to base right now, it's going to be 2, and 4, it's going to be outside. Okay, so we have x squared, it's equal to 4. Okay, so couple things here. Let me just write down. Since base is x, don't forget that what we know about the base, that the base has to be greater than 0, and base can be equal 1. So this is the information that our x has to be greater than 0 and x can be equal 1. Just remember that, because we want to avoid the extraneous solutions. So now solve for x. How are we going to solve it? We're just going to take the square root of both sides. So we're getting x is equal to x equal -2. Since x represents base, so this -2 doesn't make sense. Okay, our x has to be positive, so we're going to discard this solution. We only have one answer. X equal to, it's our answer. Okay, so it's very important that, especially with logarithmic functions, you have that extraneous solutions. Okay, so that's happening. Next, couple more. Okay, let's build a little more to what we know already. Number 99. Log base 3 of 243. It's equal to 2x plus 1. So let's change to exponential. Base it's 3. So our exponential function will be 3 to the power, and again, those expressions will switch the position. So 3 to the power of 2x plus 1 equal 243. Okay, so change to exponential, which is base, exponent equals something. So again, base is always the same as the base of logarithmic function. So now how are you going to solve that? Okay, so you want to use one-to-one property. You want to rewrite 243 as 3 to the 5th power. 243 is the same as 3 to the 5th power. So now we will have 3 to the power of 2x plus 1. It's equal the same as 3 to the 5th. Why we did that? Because now you can use one-to-one property. What that means? You can ignore bases since they are equal, and you're only going to solve the equation using exponents. Since those expressions are equal, bases are equal, that means exponents has to be equal. So you're solving 2x plus 1 has to be the same as 5. And now just solve for x. So we're subtracting 1 from both sides. We're getting 2x is equal 4 and divide each by 2. And we're getting that x is equal to. And that's our answer. Okay, so this one was the example how to use one-to-one property. Now we're going to do the opposite, okay? Next, I'm going to show you how to use logarithms to solve exponential functions. So again, here, what we did, we solved logarithmic functions. Now we're doing the opposite. We're going to start solving exponential functions. Let me see, we have 26 minutes, okay. So, here we go. Next topic is using logarithms to solve exponential equation. So the rule is, to be honest, now since you guys know both function, exponential and logarithmic, when you see exponential equations, if you can't use one-to-one property, you change them to logarithmic equations. If you see logarithmic equations, you change them to exponential, okay? So hint, we're going to change exponential equation to logarithmic equations. Okay, so let me show you how to do it using some examples from your textbook. This is number 101 from page I think 451. Okay, so you need to solve this. E to the power of 3x equal 10. Okay, so how are you going to solve it? Okay, one-to-one property won't apply because there's no way that you can rewrite E10 as a e to the power of something. So what we're going to do, we're going to change to log. So how are we going to do it? Okay, let's just remember that exponents and logs are inverses. So here, base is equal e, okay? So we're going to have log of base e, and now we need a number here, equal and number. So what's going to happen? We used the base already. So now those expressions, 3x and 10, will change the position. Okay, so next to base right now, I'm going to have 10 and 3x goes outside. Okay, so couple things, we change it. Now let's just review. Log of base e is the same. Again, log, when you see base e of 10 is ln of 10. Don't forget that when the base is e, we're just writing ln of 10. So this is equivalent to ln of 10 equal 3x. Logarithm of base e, which is ln. Each calculator has ln, so make sure that you guys will check it. It should be on the left side on your calculator. And now what we're going to do, we're just going to solve for x. you need to isolate this x, so just divide each side by 3. Couple things when you guys do it. I know it's new for you. ln of 10, this is, you treat that as a one expression, so your x will be equal ln of 10 over 3. And this is nice way to leave the answer. Okay, if you will need to evaluate that on a calculator, this is how you will type. You will type ln, the parenthesis will open, you will put 10. Okay, and then I recommend it to put that actually in extra parenthesis. Then you put division button and put 3. And that should give you about 0.77. I think that my MATLAB will ask you to leave the answer that way. Okay, this is more than fine, unless they ask you to estimate. Okay, let's do another one. Number 103 from the same page, you need to solve e to the power of 2x plus 5 equal 8. So you see exponential, we change into log. Okay, so base, it's e again. So I'm creating log, so it's going to be log. Base, it's e. So I took care of the base. And now I need expression which goes next to log, equal, and another expression. Since I'm creating inverse, those two will switch the position. Okay, so now in my log next to base, I'm going to have 8. And outside, it's going to be 2x plus 5. Okay, so we have it. Okay, the same idea. Don't forget that when you have logarithm of base e, this is just ln. ln of 8, it's equal to x plus 5. So this is one expression, okay? There's not ln times 8. This is just ln of 8, okay? It's one expression. There's no way that you can separate them. So here's solve for x. So treat that ln of 8 as a like real number, okay? Because it's a real number. Subtract 5 from both sides. So this is ln of 8 minus 5. Don't try to subtract 5 from 8. No, it doesn't work that way. ln of 5, it's real number. Okay, this is how it looks like. Equal to x. And just divide each by 2. Okay. So we're having x, it's equal ln of 8 minus 5 divided by 2. And this is how you leave your solution. Okay. That's how I want to keep it. The final answer. Don't do anything with calculator unless they ask you to do it. Okay, so this is ln of 8 minus 5 over 2. Again, that's ln and 8. Okay, this is one real number. It's not, you cannot separate them. Okay, they go together. So just remember that. Number 12, not 12, number 112. And we'll do one more word problem. 112. So let me give you one more. This is exponential 4 times e to the power of x plus 1 is the exponent equal 5. Okay, so before you change that to exponent, to logarithmic function, I'm sorry, first isolate exponential part. Which means you only want to have exponent on the left side. So we're going to divide all by 4. So divide each by 4. That will cancel, and we will end up with e to the power of x plus 1, it's equal 5 over 4. Now when you have only exponent on the left side, now it's time to change to log. Okay, so the base of my exponent, it's e. That means the base of my logarithmic function also will be e. Okay, and the remaining expressions will switch the position when you're switching. So next to log, right now, next to my base, it's going to be 5 over 4. Outside, it's going to be x plus 1. So this is how we change to logarithmic function. Okay, let's put it correctly. Log of base e is just ln. We're skipping writing that base, and you're just putting 5 over 4, okay, equal x plus 1. And now you just need to solve for x. So we're going to subtract 1 from both sides, and you're getting that x is equal ln 5 over 4 minus 1. Again, don't try to subtract 1 from 5 over 4. This one, it's together. Okay, this is a real number. Okay, don't forget. Ln of 5 over 4, it's a real number. Okay, the only way you can evaluate that, you have to use the calculator. But that's the final answer. Okay, in your textbook, leave the solutions that way. There's no reason to use the calculator. Last one, I want to talk about the applications. So we're just going to solve one word problem. Applications. So I select one problem from your textbook. This is number 121 from page 451. Let me see if actually I can, let me see if I can project that problem. So just give me a second. Let me show you how the problem looks like. $4.51. And this is number 121. Okay, so that's the problem. Atmospheric pressure. The atmospheric pressure P on an object decreases with increasing height. This pressure, measured in millimeters of mercury, is related to the height, h, in kilometers above sea level by the function P of h. P represents pressure, h represents the height, 760 e to the power of negative 0.145 h. We have to do two things. Find the height of aircraft if the atmospheric pressure is 320 millimeters of mercury. B, find the height of a mountain if the atmospheric pressure is 667 millimeters of mercury. So they give you an equation, nice, okay? P stands for pressure. What you guys need to do in A and B, you need to find height, okay? So they give you in A 320 millimeters of mercury. This is the pressure. So you're going to replace P with 320 and you're going to solve the equation for H. For B, you're doing the same type of work. You're going to replace, I'm only going to solve A. You're going to replace P with 667 and solve this equation for H. Okay? So this is what they gave us. P of H equal 760 to the power, times E to the power of negative 0.145 h. Okay, and in A, they want you to find the height when the pressure is equal 320 millimeters. Okay, so what we're going to do, we're going to replace P of H with 320. Okay, so we have 320, it's equal 760 times E to the power of negative 0.145 H. You need to solve this equation for H. Solve for H. So how are we going to solve it? First of all, maybe let's switch the side so you guys see better. Okay, first of all, what you will need to do, you always want to isolate your log or exponential expression. So we need to divide all by 760. Okay, so I'm going to divide both sides by 760, so that cancel, and then we have 320 divided by 760. Okay, so I have E to the power of negative 0.145H equal 320 over 760. Let me reduce the fraction 320 over 760. I believe both of them you can divide by 40. And that will give you 8 over 19. So we have E to the power of negative 0.145H. It's equal 8 over 19. Okay. Now what we're going to do, you have exponential, which means change to logarithmic. Okay, so we're going to change to logarithmic. The base of this exponential function is E. So base of our logarithmic function is also going to be E. Okay. Next, what we're going to do, those expressions will switch the position. So next to my base, right now, I'm going to have 8 over 19. Outside, I'm going to have negative 0.145H. Okay. Now, let's put that correctly. Logarithm of base E, this is natural log. So that means ln of 8 over 19 equal negative 0.145H. Okay, we almost have it. ln of 8 over 19, this is something what we can always plug in on your calculator. So what you need to do, you need to solve for H. So just divide all by negative 0.145. Okay, that cancel, and we having H equal ln 8 over 19 over negative 0.145. So how to evaluate that on a calculator? Okay, so to use your calculator, again, depends which one you use it. First, what you want to do, I will type ln, and in parentheses you put 8 divided by 19 because fraction bar means division. And then I will click enter. You will get your answer here, right? So you're going to get some answer here. And then my answer, because you guys have most of your basic calculator, whatever the answer you have it here, just divide that by negative 0.145 and then click enter. And your calculator should show you the correct solution, which is 5.97. And going back to that problem, the height was expressed in kilometers. So this is our answer. Okay, B, we're doing the same thing. You have to solve for H. Okay, so that's it of section 6.4. Okay, guys, study, so work on the problems. Okay, let me know if you have any questions.